Hey guys, so our lesson today is going to now be factoring trinomials when the a value is equal to 1. So if we think back and look at what trinomials are, right? Trinomials are essentially just a polynomial that have three terms, right? In this specific case, when a is equal to 1, right? If we look at our standard form, we have ax squared plus bx plus c, where a, b, and c are all just constants, right? And we're going to talk about how we can factor those specific types of trinomials when that a value is equal to 1. Okay, it's a very simple trick that you guys are going to be doing. Essentially, what you need to find out is you need to find two numbers that multiply to the c term, right? So that'll just be that plain old basic number at the end. And then the same two terms also have to add up to the b value, so whatever that b number is there. Okay, as I'm going through these problems, I'm going to be showing how I want you guys to be showing your work for when you submit your homework on this, okay? So just kind of bear with me as I go through these. I'm going to kind of go through each example very specifically, and I'll write out and show you guys how I want you to be showing your work on your paper, okay? So first things first, it says factor x squared plus 7x plus 10. So if we look at the a value, right, technically there's no number in front of x squared. There's just that imaginary 1, right, a placeholder of 1. You don't need to write a 1 in there. That's just to remind you guys that technically, again, that a value is actually equal to 1 there, okay? So all we're trying to think of right now are what two numbers are going to add up to our b value and multiply to our c value. So first thing I want you guys doing is just writing under the expression here that a equals 1, b equals 7, and c is equal to 10. Okay, so do we check a is equal to 1? Yes, it is. Okay, so now all I have to do is figure out what two numbers are going to add up to 7 and multiply to 10. Some of you guys might benefit from actually writing out the factors of the number where you're trying to find the two numbers that multiply to it. So for example, for 10, you could write out the factors of 1 and 10, 2 and 5, I think that's it for 10. And you guys should pick up on the fact that 2 and 5, right, those two numbers multiply to 10 and they add up to 7. So showing your work for this, you're just going to take those two numbers and just write under it, right, 2 plus 5 we know is equal to 7. And then we also know those same two numbers, 2 times 5 is equal to 10. Okay, so once you have those two numbers, it's a very simple setup. You're going to be writing, right, a set of two parentheses. Okay, they're both going to start off with a positive x and positive x, because technically that x times x is going to give you that x squared term. Now all you have to do is take those two numbers and pay attention to the signs, right? They're both a positive 2 and a positive 5. So I'm going to write plus 2 and plus 5, okay? It doesn't matter the order. You could have written x plus 5 times x plus 2. Doesn't really matter because, again, you're multiplying. Order doesn't matter, okay? So your final solution, factored, would just be x plus 2 times x plus 5. You could always go back and double check, guys, just by foiling or multiplying those two binomials to see if you end up with the original trinomial there. All right, so example number 2, okay, same idea. I want to find two numbers now that add up to a negative 3 and multiply to a negative 4. So again, what I'm going to do, I'm going to just write it right out under a is equal to 1, b is equal to negative 3, and c is equal to negative 4, and I want to think of two numbers, right, that add up to a negative 3, but they also multiply to a negative 4. So you got to be careful with your negatives here, right? So with 4, my only factors are 1 and 4 and 2 and 2, okay? Now I can manipulate the 1 and the 4, right, to get a negative 3 and also to multiply to a negative 4. So let's say if I make that a negative 4, right, technically negative 4 plus 1 is equal to negative 3, and negative 4 times 1 is equal to a negative 4. So my two numbers are going to be positive 1 and negative 4. So that'll be written as x plus 1 times x minus 4. All right. Moving along to example number 3. Okay, so again, two numbers that are going to add up to a negative 7 and multiply to a positive 12. Let me run through my check here. A is equal to 1, yes. B is equal to negative 7. And c is equal to 12. So thinking of factors of 12, right, I have 1 and 12, I have 2 and 6, and I have 3 and 4. Now here's the catch, though. They have to multiply to a positive 12 but add up to a negative 7. So I can take that 3 and 4, and if I make that 3 and 4 both negative, right, a negative 3 plus a negative 4 equals a negative 7, and a negative times a negative we know is equal to a positive. So negative 3 times negative 4 is going to give me a positive 12. So I'm going to factor that as x minus 3 times x minus 4. Okay, and guys, if I'm going too fast for you, feel free to pause the video, go back and kind of rewatch each example a couple times, all right? That's the nice thing about these videos, you can kind of go at your own pace. All right, now example 4, okay? So now here, again, there's no technical number in front of my minus x here, so I'm just going to put a little placeholder of 1, all right? So two numbers that add up to a negative 1, but multiply to a negative 90, all right? And that's a pretty big number, so let's take a look at that. So again, I know here a is equal to 1, right? Placeholder of 1. I know b is equal to negative 1, and c is equal to negative 90. So if I go ahead and just list out some, on top of my head, factors of 90, so I now have 1 and 90. If I cut in half 90, I have 2 and 45. I think it's 3 and 30, right? We'll list them all out. And I can just take a calculator and do this, right? 90 divided by 5 is 18. 90 divided by 6 is 15. And then we know 90 divided by 9 and 10. That's an easy one because we know 90 ends in a 0, right? So anytime you guys have a number ending in a 0, always check to see when you divide it by 10 if that other factor is a perfect square. Well, just test out all your options, okay? So perfect square doesn't matter here. So 9 and 10, right? If I manipulate that 9 and 10, I can multiply them together to get a negative 90 and also to add up to a negative 1. So meaning I'd have to make my 10 here a negative, right? So again, showing my work, that's going to be 9 plus a negative 10 equals negative 1. And then 9 times a negative 10 is equal to a negative 90, okay? So again, how I write that is just x plus 9 times x minus 10. Okay, so those are your first 4 examples. Now what I need you guys to do is that if a doesn't equal 1, you guys can still actually use this method, but you have to first see if there's a greatest common factor, right? So see if there's a common number or term that goes into all 3 terms there. All right, so looking at example 5, usually what the deal is here, guys, is whatever number your a value is, usually that can go into the b and c value. So first off, just take, okay, well, my a value here is 3. Is that divisible into my other 2 terms, right? So let's go ahead and just list this out. So I have a is equal to 3, b is equal to negative 3, and c is equal to negative 6. So again, since a is not equal to 1 here, do I have a common factor between 3, negative 3, and negative 6? Yeah, I can divide out of 3. All right, so if I factor out that 3, I'm now left with, okay, 3 times what gives me 3x squared? Well, that'll be an x squared, right? 3 times x squared is 3x squared. So now again, 3 times what is going to give me a negative 3x? That would just be a negative 1x, right? 3 times a negative 1x is negative 3x. And then 3 times what gives me a negative 6? That'd be a negative 2. Now here I have a is equal to 1, right? B is equal to negative 1, and C is equal to negative 2. Now I can go back and use that same method that we did before, right? What 2 numbers are going to add up to a negative 1, but multiply to a negative 2? So the only factors of 2 are 2 and 1, right? So how can I manipulate 2 and 1, where they add up to a negative 1 and multiply to a negative 2? We'd have to make that 2 a negative, right? Because negative 2 plus 1 gives me a negative 1, and then negative 2 times 1 gives me a negative 2. So when I write my final answer, yes, you're still going to do it as x minus 2 times x plus 1. But remember, you factored out that 3 in the beginning. That needs to be part of your final answer there. All right, so make sure you guys include that 3. Okay? All right, example 6. So I'm looking at 2x squared minus 12x plus 16, 2, 12, and 16. So again, since we have that 2 there, and those are also even numbers, we can go ahead and factor out that 2. Let's go start by factoring out my 2 here. So I have 2 times x squared is going to give me 2x squared. 2 times a negative 6x will give me the negative 12x. And 2 times a positive 8 will give me the positive 16. Now I have a is equal to 1, b is equal to negative 6, and c is equal to a positive 8. So once again, 2 numbers that add up to a negative 6, but multiply to a positive 8. So again, my factors of 8 are just 1 and 8. And 2 and 4. So I can manipulate, I think, that 2 and 4, where they have to multiply to a positive 8, but add up to a negative 6. So if I make both of these negative, right, a negative 2 and negative 4, negative 2 plus a negative 4 gives me the negative 6, and negative 2 times a negative 4, negative times a negative, gives me a positive 8. Okay, so that's what it's going to look like is x minus 2 times x minus 4. And do not forget, we factored out that 2 in the beginning, so that has to also come back out in front here. Okay. All right, our last two. Okay, so example 7 is 2x squared minus 22x plus 28. Again, with that 2 being an even number, right, and that can be divisible into 22 and 28. Let's go ahead and pull out that 2. And I'll fill in here. So 2 times x squared is going to give me 2x squared. 2 times a negative 11x is going to give me a negative 22x. And then 2 times a positive 14 is going to give me the 28. So again, I'm trying to think of two numbers where, again, a is equal to 1, b is equal to negative 11, and c is equal to 14. Two numbers that add up to negative 11 and multiply to 14. Now, my only factors of 14 are 1 and 14 and 2 and 7. So the difference between 14 and 1, right, that would give me a 13, which is not going to help me because I need 11. And if I add or subtract my 2 and 7 here, that's not going to give me a negative 11 either. So we're actually stuck here where we actually cannot factor this trinomial. So my final answer is just going to be 2 times x squared minus 11x plus 14. I cannot factor any further. That might happen a couple times, guys, so just be on the lookout for that where it is possible that sometimes these trinomials cannot be factored any further. Okay? All right, and our last one for example number 8, we have 3x squared minus 33x minus 36. So now with that coefficient of 3 here, or that leading coefficient, I want to see does 3 go into 33 and 36? Yes, it does. Let's go ahead and factor that out. That's my greatest common factor. So I know 3 times x squared is going to give me 3x squared. 3 times a negative 11x will give me a negative 33x. And 3 times a negative 12 is going to give me a negative 36. So I see a is equal to 1, b is equal to negative 11, and c is equal to negative 12. And I'm trying to figure out what two numbers add up to a negative 11 and multiply to a negative 12. So again, factors of 12, I have 1 and 12. I have 2 and 6, and I have 3 and 4. So I'm trying to think of which ones I can manipulate to add up to a negative 11 but multiply to a negative 12. I'm going to use these first two factors here, right, the 1 and the 12. I can make that 12 a negative because negative 12 plus 1 is a negative 11, and then negative 12 times 1 is a negative 12. Okay, so I'm going to write that down here. I'll do a negative 12 plus 1 I know equals negative 11, and negative 12 times 1 gives me a negative 12. So I can write this as x minus 12 times x plus 1. And then once again, I factored out that 3 in the beginning. Make sure you guys include that in your final answer. Okay, so this is your instructional video for today, guys. Make sure, again, when you guys are going to be submitting your classwork, in order to get a full completion grade, I need to see this work here, right? Identifying your A, B, and C, picking out the two numbers, showing how they add up to the B term and multiply to the C, and then your final answer. Okay, make sure you're clear with that so I can read it. Questions, guys, feel free to email me or private message me. I'll be on the clock. All right, take care. Bye.